These notes are covering section 2.5, equations of lines and linear models. So some of you may have seen some of these equations before. We're certainly, you're certainly familiar with y equals mx plus b, the equation of a line that has is in slope-intercept form. We've actually talked about that back when we were discussing linear functions. But now we want to introduce another type. Again, some of you may have seen this before, but for some of you, this is a brand new form of the equation of a line. So it's called the point slope form. So in this equation, y is going to be a variable, and so is x going to be a variable. Y sub 1 and x sub 1 are the coordinates of a point. And then m, of course, is the slope. So let's use this equation. We did a similar problem the other day where we found the slope. And then we, on top of finding the slope, we also went and found the equation of a line. And we put it into slope-intercept form, temporarily plugged in an x and a y value with our slope to find our b, but this sort of allows us not to have to do that sort of extra step. So hopefully it'll become clear when we go through the example. So it says write an equation of the line through these 2 points, and then we'll also write it in standard form. We talked about standard form the other day. That's the ax plus by equals c form, where the a, the b, and the c all have to be relatively prime. So we talked about that. So we'll put it into, and I'm going to put it into slope-intercept, point slope form, because basically it's a little bit easier than going back and using this form all the time. So let's do it. So first we want to do is find the slope, right? In order to write the equation in point slope form, you need the slope, you need a point, and you need the slope. So we have points, we have 2 points. So what we really need is the slope. All right, so the slope, and we can take, say, for example, 3 minus a negative 1, so plus 1. So the difference in the y's over the difference in the x's. Now I started with this y, so I have to start with this x, negative 4 minus 5. And that gives us positive 4 over negative 9. So that is our slope. You can either put the negative upstairs or down. So we could think of it as negative 4/9, or we can think of it as 4 over negative 9. All right. So now I have the slope and I have an abundance of points. I mean, I have 2. I only really need 1. So I'm going to put it into this form. So we have y equals, and then the y coordinate. I'm just going to go ahead and just pick this first point. Doesn't matter. I'm going to pick that one. So not y equals, sorry, y minus 3. So y minus 3 is equal to the slope, negative 4/9 times x, and that's minus the x coordinate. In this case, it'll be minus a negative 4 or plus 4. So that, boom, you're done. That is an equation, a perfectly acceptable equation of the line. So it says equation of a line, doesn't say which form. This one's perfectly acceptable. You don't have to go find specifically the y-intercept like we did the other day. All right, but now we do want to write it in this form. And so that means we want to simplify this. We want to move the x's and y's to one side, the constants to the other. So let's take this and then write it in the standard form. So I'm going to have y equals, and then that's going to be negative 4/9 x. I'm distributing that, minus 16/9. Now I'm also bringing the 3 over, but I'm going to want to combine it with the 16/9. So probably I'll write that as plus 27/9. So the 3 becomes 27/9. All right, and then I'll bring this x term to the left. So we have negative 4/9 x plus y. equals, and when I combine these things, I should get something like 11/9. All right, and then really your A, your B, and your C should be whole numbers. So we don't really like them to be fractions. So I'm going to multiply through by 9. And we could have done that up above here to get rid of the fractions, back up when we were doing this. But soon, one way or another, we want to get rid of those. So when I multiply through by 9, that gives me negative 4x plus 9y equals 11. All right. And so I know some people have probably been told in standard form, like, don't start with a negative. You can. I mean, if you wanted to, we could certainly multiply through by a negative 9, and that would have given us 4x minus 9y equals negative 11. But this one's perfectly acceptable. There's nothing wrong with A being a negative. Okay. So that is standard form. Notice the 4, the 9, and the 11 are mutually prime or relatively prime. They don't have any common factors among them. They're no longer fractions, and they have no common factors. So that is true standard form. Okay, the next form we already used. We dealt with it before when we were calling y f of x, and we are calling it a linear function. But now we're talking about equations, so we tend to use y instead of f of x. All right, again, m is the slope, b is the y-intercept. Find the slope and y-intercept of the line with this equation. So they give us the equation. This is in standard form, and it's not true standard form because those are not A, B, and C are not relatively prime. But it's in this form. Find the slope and the y-intercept. So the easiest thing to do would be to take the standard form and turn it into slope-intercept form, because then we, boom, know the slope and we know the intercept. All right, so I'm going to do that. We're going to solve it for, move the x over, solve it for y. I'm going to start way over here. Negative 3y is equal to negative 6x plus 9. So I subtracted 6x from both sides. Now let's divide through by negative 3y is equal to, that'll be 2x minus 3. And so since we have that, we can very quickly, easily say, okay, so that tells us this m, the slope, is 2. And that the y-intercept, if we want to just call that b, that's what we generally use as b, we know that is this thing here, negative 3. Okay. All right, example C. Find the equation of the line through these 2 points and then graph the line. All right, so let's find the equation. Now, it doesn't say what equation, so we don't have to use slope-intercept form. We could use point-slope form. All right, and then we also want to graph it. So in order to graph it, we would need to have the slope and 1 point. If we know those, we're done, and we can just graph it very quickly. All right, so let's find the slope first. So m is equal to, I'm going to say 4 minus 2 over negative 2 minus 2. And so that is 2 over negative 4, or negative 1/2 is our slope. All right, and then, you know what? Let's go ahead and just find all 3 equations, all 3 forms of the equation. First one I'm going to do is point-slope form. And so I'm just going to pick this point. And so we do y minus 4 is equal to the slope, negative 1/2, x plus 2. And so it doesn't say what equation of the line to use. So point-slope, perfectly acceptable. We could convert this to slope-intercept form, y equals mx plus b, move the 4 over, distribute the negative 1/2. So we get y is equal to, that'll be negative 1/2 x. The 1/2 gets distributed to the 2. That's negative 1 plus 4. So that sounds like plus 3. And so that is slope-intercept form. And now let's put it in standard form. So I'm going to bring the negative 1/2 over. That'll be 1/2. Let's go ahead and multiply everything by 2 as well to get rid of the fraction. So that will just be x is x plus 2y is equal to, and we're multiplying through by 2, so that's 6. So here are the 3 equations. They didn't ask for all 3, but certainly any one of those would have sufficed when it said write the equation of a line. I think, honestly, the point slope form is probably the easiest. You just need a point, and once you find the slope, you can just write it very quickly. All right, so we know how to graph using this form, but I'm going to graph using the point slope form. So again, all I need to graph a line is the point and a slope. So the point is, I'm going to use the point negative 2, 4. Let's see, let's put the XY axis in something like this. It's negative 2, 4, so maybe put it here, the Y axis. And then let's plot our 1 point, negative 2, 1, 2, 1, 2, 3, 4. So here is the A point that's on our line. And then let's use negative 1/2. So I'm going to go down 1, which is negative, to the right 2, and down 1 to the right 2, down 1 to the right 2. Or I could go up 1, which is positive, to the right 2. So in other words, I think of this slope as either negative 1 over 2 or 1 over negative 2. So right now I'm going a rise of 1 and a run to the left of negative. So I'm kind of thinking of it this way. Here, when I was going down, I was thinking of it as negative 1 as the rise and the negative rise, but a positive run. All right, so you can kind of keep just plotting points there, and then let's kind of draw that in there. Okay, and so you would get that same line if you started with this, right? The y-intercept of 3 and a slope of negative 1/2. You could kind of plot from this, looking at finding your x and y intercepts. Put a 0 in for x. That gives us a y-intercept of 3. Put a 0 in for y. That gives us an x value of 6. I didn't set mine up to kind of show that exactly, but 1, 2, 3, 4, 5, 6. This point would have, gone through here. So you could use the standard form to plot the line using sort of your y-intercepts, your x and y-intercepts, and then slope-intercept. Of course, you use your y-intercept and your slope. And then this one would be just any point, the point you use, in this case, negative 2, 4, and the slope. All right, next thing, equations of verticals and horizontal lines. We talked about this the other day when we were talking about slope. We went ahead and took the examples from the notes the other day and took them further and said, okay, well, let's write the equation. So x equals a value. This is going to be a vertical line. All the points have the same x coordinates of A, and so that will be a vertical line. Y equals B will be a horizontal line. All the points have the same y coordinate, so they're all next to each other, so it would be a horizontal line. All right, parallel lines. Parallel lines, these are, if we're talking about two distinct and they're not vertical, then the parallel lines are going to have slopes that are the same. We say can't be vertical because vertical lines are going to be parallel, but their slopes would be undefined. If they're vertical, our slopes are undefined. So that's why they say non-vertical, but parallel lines are going to have slopes that are the same, assuming they actually have a slope. All right, so we're excluding vertical lines there. So that's parallel lines. And then perpendicular lines, they're going to have slopes that are negative reciprocals of each other. So two distinct lines. We're not talking about things that are either vertical or horizontal, right? Because then we're talking about a vertical line and the slope is undefined, so we can't take the negative reciprocal of a 0. And so there are two distinct lines. If they're perpendicular, then we know we have the product is equal to -1, so that just means they're negative reciprocals. So if the slope for one is -1/2, the slope of the perpendicular line will have a slope equal to positive 2, the product of which is negative 1. So another way of saying that their products have to be negative 1 is that those two slopes are negative reciprocals of each other. All right. Since vertical lines have slopes that are undefined, they do not follow the rules for parallel and perpendicular. Okay, we already talked about that. We know that all vertical lines are parallel and that a vertical line and a horizontal line are perpendicular. But again, because of the restrictions on the slope being undefined, we can't really apply them to the rules we were just talking about. All right, make sure that you look on page 240 of the textbook for similar lists of information about the equations of lines. So make sure that you go and look at that. All right, the back then of these notes, continuing on section 2.5. All right, so now let's practice some of these things we just learned about parallel and perpendicular lines. So an equation, write an equation in both the slope-intercept and standard form we probably good practice just to do all three of them, of the line that passes through the point 2, -4, and that is parallel to this given line. Okay, so we know the equation of a line. Our line that passes through this point 2, -4 is parallel to this line. So think about what we need. We need to find the slope. So let's find the slope of this line that they gave us that is parallel to ours, and then we'll know that our slope is the same as this line. So I'm going to take this one and just rewrite it. -2y equals a -3x plus 5. And then let's divide through by -2. So we have a slope of 3/2 x minus 5/2. All right, so what we want is the slope is 3/2. And so if their slope of this other line is 3/2, that means ours is parallel. So ours is also 3/2. All right, so let's go ahead and just put it in point slope form. So we know a point that it goes through. So we have, again, y plus 4. We're just simply plugging the coordinates in. Sorry, that's off your page there. Y plus 4 is equal to the slope, 3/2 x minus 2, which is the x coordinate of that point. Okay. And so that is point slope form. They didn't specifically ask for that, but not bad to start with that. And then if you want to put it into slope-intercept, you can just manipulate this. So y is equal to, let's distribute. I'm going to move this 4 over. So let's distribute the 3/2. So 3/2 x minus, when I distribute that to the 2, I get -3. But I'm also going to be bringing the 4 over. That's going to be negative, so -7. Okay, so that is our slope-intercept. I think it might just be easier to go ahead and do that rather than plugging temporarily our x and y values into this form and then solving for the b. But, if you want to keep doing that like you've learned in previous years, that's fine. And then finally, we want to turn this into standard form. I'm going to bring the x over. That's going to, and then also multiply by 2. So that's going to be a -3x plus the y, but I'm multiplying by 2. So 2y, and that's equal to -14. Also got multiplied by 2. All right, so those are the three equations that would be possible for the line that's parallel to this one, going through this point. All right, now we're given one that's perpendicular. So this line is now perpendicular to our line. It's the same equation here, so we can very quickly say, oh, okay, the slope of their line is still 3/2 because it's the same line that we were just dealing with in part A. So what is our slope? Our slope is the negative reciprocal, -2/3. So you flip it and you negate it. You make it the opposite. Okay, so let's write those equations. All right, so we get, again, point slope y plus 4 is equal to -2/3 and then x minus 2. Okay, so that's point slope form. Let's turn it into y-intercept form. Let's see, y is equal to negative 2/3 x. When I distribute this, I'm not going to try to do too much in our heads here. We might just put another step in here. We have a plus 4/3, and then I'm bringing this 4 over, and it's negative, so that's going to be negative 12/3, right? Probably good to put an extra little step in there. And then let's hang on, let's box this in. That was our first equation in point slope. Now let's finalize this. Y is equal to negative 2/3 x, and then minus 8/3. Minus 8/3. Okay. And then finally, let's multiply through by 3 and bring this term over to the other side so we get it in standard form. So I'm going to bring it over and multiply by 3. So we get 2x plus 3y equals, and then negative 8. Okay, and so that is our standard form. All right, then next, we want to look at a sort of a model. The average annual tuition and fees for in-state students at public four-year colleges is shown in the table for select years. There, that's a little bit better maybe. For selected years and graphed as ordered pairs of points where x equals 0 represents the year 2009. So this year here was 2009. Okay. All right. So, and then of course, x1 equals 2010 and so on. Y represents the cost in dollars. All right. Find the equation that models this data. All right, so this is not necessarily a perfect line. I'm going to try to look for a ruler. Do I have a ruler anywhere? Well, not the best ruler in the world, but you can see if we put a ruler down here that these things are not perfectly in a line, right? A couple of them might be actually on a line, but overall they're sort of not on a line. So we're thinking about like, oh, what would be the best fit line, right? So some calculators will calculate the exact best fit line. And so what we really want to do is just pick some values, a set of points that we can write the equation for. So that would be a lot like what we did in number 1, right? So example A on the other side, we had 2 points. If we have 2 points, we should be able to write the equation of the lines. And so that's kind of what we want to do here. And so we just want to pick 2 of these points that we think are sort of representative. I picked this point and this point, right? Those 2 sets of coordinates. You can really pick any pair you want. Sometimes we pick like the outermost 2. So I just picked these 2 sets of data. So I'm using the point 2010, comma 6695, and 2012. 703. So I'm using those points. Now, I mean, you could also kind of think of this as, should we use, here we were using 1, 2, 3, 4. Here in the table, we're using actual years. If we're going to plot the data and use this graph, maybe it'd be better to use 1s and 2s and 3s. But I'm going to use the actual years in here. At least let's do that to find the slope. All right, and so that it really doesn't matter because the difference of these is going to be the same whether we're dealing with 1, 2, 3 or the years 2000s. Okay, so let's find the slope first. So the slope is, let's do 7,703. minus 6,695 over 2012 minus 2010. All right, so when we subtract the top numbers, we end up with 1,008, and on the bottom, 2. And so we get a slope of about 504. All right, now 504 is a slope of the line that I picked that goes through these 2 points. Those are the points I figured are representative of the best fit line, but you could, you're going to get a slightly different slope if you picked different points. All right, so mine came out to be 504. You'd expect most of them to be similar to that. So let's do the following. Let's then find the equation that models the data. So I think I will use these when I go to plug points in instead of these, because we're trying to look at the graph. So I'm going to do point slope form. So we have y equals, let's do y minus point slope form. And so I'm just going to use this point that we used here. And so instead of 2010, I'm going to count that as just 1. So I'm going to do y minus the y value, 6,695, equals, and then the slope 504 times x minus, and now instead of 2010, I'm just going to put a 1 in there. Okay. But you might just as well put in 2010. It just depends on whether you want to use as your x values the actual year, or how we've converted it just to make the graphs a little bit simpler. All right, so that is, that's a perfectly good equation, right? I mean, it doesn't say what equation to use, so that's a perfectly good equation. But let's go ahead and then convert that to just simply y equals mx plus b. So let's see, we'll want to distribute this. We get 504x, and then we distribute to the 1 as well, minus 504, and then plus the 6,695. Sorry, I almost ran off the page there. And so finally, we could write this as y is equal to 504x plus, when we combine these two constants, 66,191. So either one of those probably would be a good, we could very quickly get a standard form. If we want it, just take this x value to the other side. But, it doesn't say exactly which form of the equation they want. So, either one of those would probably be acceptable. All right, and then the last one here, use your equation to predict the cost of the tuition and fees at the four-year college in the year 2015. So let's think about what that would be, right? So this is 0, 1, 2, 3, 4, and then 2014 was 5, and then 2015, that would be sort of an x value of 6 if we are staying with our x value being similar to what the table was rather than what the graph was. So we'll use an x value of 6. And so we just plug it into any of these equations, and probably this one is the easiest one to use. It's already been distributed and whatnot. So this last equation is the easiest one. Y is equal to 504 times 6 plus 6,191. And so that's just pure calculator work. Let's see, I ended up with $9,215 is my estimate. Now, of course, that estimate's going to be different if you use different points, right? So if you use 2 different points than me, your slope's going to be different, your equation's going to be different, your y-intercept is going to be different, so your prediction would be slightly different as well. So, in a quiz or a test, I would give you the prediction equation or somehow tell you which points to use. Otherwise, I mean, it might be that they're all perfectly on a line, in which case it wouldn't matter. But here it does matter because they don't all fit perfectly on a line. All right, so your homework from this section is the multiples of 3, 18 to 66, the multiples of 3. That is due next class.